That's better. All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to be doing a bit of Rust basics studies, I guess. I'm not sure what to call it. Give me a second. Let me position my uh, model here. Um, Give me a second, and I think we're good. Is that okay? That's okay. I think that's okay. Yeah, yeah. So, well, unfortunately, today as well, I started the stream late. I need to get better at, well, starting the stream early. Um, yeah, yeah. I don't know what else to say. I need to get better at that. Um, Hold on. Well, okay, yeah, yeah. I need to starting the stream earlier. I just got busy with something and then I got carried away with some other research that I was doing and it just kind of got away from me. So, yeah. Okay, now, for today's stream, mainly what we're going to be focusing on is where exactly was this? I can't remember exactly where this was. In this example of the the clap crate, we have this match thing. In addition to match, oh, here. So we have if let here, right? So I was doing some research on this, and that led me to, I don't remember if I Googled it here or elsewhere. Give me a second because I cannot remember what all tabs I have open. So I'm just gonna check on that real quick. Actually, while I'm here, I might as well, you know, um, yeah, yeah, okay. So I'm just gonna look up Rust if let. I'll open up that page and then we can continue. Because in this on this page they teach not just if let but also if let else and then also let else. So that was kind of like mind blowing for me. I was like, hold on, I didn't know all of this is possible. Give me a second. Let's transition back. Let's also before I forget, let's also refresh the RTMP feed and we should be good to go. Right. Now, um, today, pretty much all I want to focus on is this thing. There's iflet, and then it goes down to where we are able to add an else statement in iflet, and it goes down further to where we are able to add. Where is that? There's iflet else. Where's the let else? It's supposed to come in here, right? Yeah, yeah. So here they are showing that, okay, you could do so and so thing. You could use if let and then else, and then within that you can have your conditional statement. But then they also show that instead of that, you could do something like this. So it's let, and we give the name of the variable, and then within that we have the if let expression, because expressions return a value. So we are able to use this entire expression actually. So we are able to use this. Actually, I don't know if expressions always return a value, but this specific one does return a value. And so because of that, we can set it up such that this thing, it returns the value to state. And if the condition is not true, then in else, we can do return none. And I'm actually surprised that it's not forcing you to give a condition for else. Though, I mean, there have been situations where it just doesn't. Actually, in general, it doesn't force you. It's not like match. For match, it'll force you to, you know, wait, give me a second. Yeah, for match, it'll force you to have like all of the match arms, and at the end, or like if you don't want to have all the match arms, then I guess for that you can have the words. Oh my god. If you don't want to have all the match arms, then you can have just a sort of I think it's called a discard pattern or wildcard or something like that. Pattern matching match. Let me open this up. So here we have this. Okay, okay. So as you can see here, this is a perfect example of situations where match would be useful. Um, but in general, I think even just like a general thing, it doesn't have to be um it's not like exclusive to enum. Initially, that's where my mind was going, that oh yeah, this might be exclusive to enum, but no, it's not. Like kind of like in C sharp, you have the switch case thing, right? You can use that for various purposes. You can do the same thing with match as well. You can have like literals and have behavior based on that. I don't remember exactly how that works. I think it's as simple as just like having the literal there. Like let me try um hold on. Okay. All right. Okay. Now in here we have A. So what I'll do here is say match A, and then here we can have if it's 0, then print line 0. Um, if it's 5, then print line 5. Um, Otherwise, so for that we'll have this. Otherwise we do, wait, actually, I don't need to put tab there. Yeah, otherwise we'll say something else. Oh, wait, what's going on? Oh, yeah, yeah, it's not supposed to be. Why did I do this? I don't remember why I did this. Are we good now? Now we are good. Okay. So let's run this and see. Oh shit. What just happened? Okay. Cargo run. Wrong thing to run. Um bin sum o one. Is that what's, yeah, sum o one. Okay, 5. And if we change it to 6, then it says something else. So this is how our regular match thing works, right? Um, Actually, hold on. Match might be specific to that, right? No, sorry, match might not be specific. Match can be a more general purpose thing, like I just demonstrated. It's not specific to, enums. I wonder if let is specific to enums. Yeah, yeah. I wonder if let is specific to enums because we're doing pattern matching for if let, and then the value gets stored in. How would I set up that example? Uh, hold on. Let me try asking Gemini if let and let else. Okay. Hey, are if let and let else in Rust exclusive um, to enums? I'm trying to think of other situations where we might use them. Okay, the short answer is no, they're not exclusive to enums. While you see them used with enums like option and result, about 90% of the time, if let and let else can actually be used with any irrefutable or refutable pattern in Rust. This includes structs, tuples, slices, and primitive values. Here's a breakdown of how this works beyond enums using iflet with structs and tuples. Okay, iflet user so and so. Okay, this is an example that Gemini has given. Let me just copy and paste this. Okay, we're gonna paste that, and then in here we are writing this. Wait. Okay, so this is the example. Wait. Okay, all right. Um, So we have a user struct. The struct is created with this. So it's name dot toString. Okay, all right. We only care if the user is an admin. So we are checking the true thing. We only care if the user is an admin. If so, we grab their name. How is that working? Oh, we're giving a name here, right? User over here is the variable that we are doing the pattern matching on. That's an instance of our struct. And here we are giving this condition. That's so interesting, dude. Wait, that is so interesting. So the name can I would I be able to change the name here? Let's say name O one. Let's say name O one. Okay, and name O one here as well. No, we can't do that. Wait, that's so interesting. We are able to use the field name itself, um, which I mean, it shouldn't be that surprising to me because usually, like if we want to access the name, we would do user dot name, right? Here we don't need to do that. It's just kind of surprising to me that we are able to specify, first of all, the fact that we are just using these names as they are without doing, user dot so and so. This is an interesting way of doing it. Um, and then additionally, we are able to give a condition in here. In the other example, did we have a condition? I don't think so. Like, what if I wanted to, okay, let's try this pattern matching. Okay, let's do that. And let's try pattern matching here. Um, okay, so let's do if let a equals 5, a. Is that gonna work? No, we are doing. What about this? Yo, wait, that works? That works? So if I just type 5, oh, there's an issue here. Get rid of that. That works. And then we can do this. Um, let's say something else. That's crazy, dude. I didn't know that we are essentially putting. Yeah, okay, that kind of makes sense if we look at the example that see this tells me that I wasn't properly understanding what exactly I was reading, what I was learning. Because now the dots are connecting for me. Now it's all clicking, and I'm like, holy shit. So we specify a condition in here, and if there are additional members for the type, because in this case we only had like one value, right? But if it's something like a user, okay, can I create a second thing here? Hold on. Is there an else if? Would that work? Name uh hold on. How do I do this? How do I pattern match against yeah, no, how do I do this? Would a string wait, let's create two things, okay? Str01 equals string from ABC, okay, and then increment that. And now, if str01 equals str02, I have no idea how, like, what exactly it's pattern matching, or sorry, what exactly it's comparing between the two. But yeah, let's do that. I guess the behavior of that would depend on if behavior has been defined for an equals operator. Like for string, if there is behavior defined for the equal operator. Let's do print line, str01 and str02 are equal. Okay, there is behavior defined. Let's do this. Okay, so it's comparing the string data that's held inside. Though I feel like it might be a little more complicated than that. Yeah, no, I feel like it might be a little more complicated than that. Do I have access to string here somehow? Wait, let's open this, come here, search string. Not to string. Oh, wait. Hold on. Wrong thing. I'm not supposed to be looking in quad. Uh, wait. Let me look it up elsewhere. Hey, in Rust, when I use equals equals to compare two string objects, what exactly is being compared? You are comparing their actual textual content, that's the characters, not their memory addresses. Under the hood, Rust automatically dereferences the string objects into string slices and compares them byte by byte. Here's exactly what happened. You know what? Okay, I'll let that go for now. And apparently, string implements partial ec or partial EQ, which is why we are able to use the equals like comparison operator. Give me a second here. Okay, all right. All right. So, I can move on from this and come back to learning about uh, how iflet would be used. Also, I forgot why I was doing this. The string thing, I forgot what brought me to it. Oh, yeah, it was because of this. So iflet user name string fr from Alice, and then just admin. So we don't specify anything for admin. This is probably not going to work, right? Because the value is being moved up here. Expected tuple struct or tuple variant. Uh, Found associated function. Why is it expecting a tuple struct? Okay, what if I did this? Mismatch types. Okay, I gave it the type that it was expecting. How do I wait. Okay, using let else with chained matches. Introduced in Rust 1.65, let else requires a refutable pattern, a pattern that can fail to match and must diverge, example, return, break, etc. just like if let, it works perfectly with tuples or arrays when you only want to proceed if a specific value is present. The core concepts, refutable patterns, to understand why they aren't exclusive to enums, it helps to understand refutability. Irrefutable patterns, patterns that cannot fail to match. For example, let x equals 5, let a b equals 1, 2. Rust will actually give you a compiler warning if you try to use if let with these, because a plain let works just fine. All right. Um, wait. So we do let else. Give me a second. Yeah, okay. So we do let else. With let else, let's do that here. So we did the pattern matching thing, right? Um, so we did if let a and so and so. Uh, Apparently we can do this as well. Let a how do we do this? Oh, let a equals 5. Is that how? Wait, no, I'm getting this wrong. We only want to proceed um if the x coordinate is exactly 0. All right. Uh so to recreate that here, the only way to like recreate it is first of all we have to return, right? And yeah, these two have to be switched. Um Let else does not diverge. So we'll do this print and then we'll return. Expected so and so found let. Did I forget something somewhere? Um oh, right. So this returns from here. Let 5 equals a, else so and so. It does whatever it needs to do and then returns out. So this is if we want a divergence. If the value is true, then we basically proceed to the remaining stuff here, which means it is going to print out 5. Let's say not 5, and then it's not going to print that out. So yeah, it prints out 5, and if I increase this, it prints out not 5, and it doesn't proceed. All right, okay, that's interesting. I didn't think about the divergence thing. This is actually really useful if you ever want to like exit out of a function. Though it's not, from what I understand, it's not limited to just functions. Yeah, it's not limited to just functions, because I think break and continue also work here. Yeah, it says It requires a refutable pattern. Let else requires a refutable pattern and must diverge. Example using return, break, continue, or panic. Break would mean we are able to break out of a loop from this. Panic means we just break out of the program. Um, Continue is interesting because that would mean we get like the opposite. So if the value is not true, then we continue, or if the condition is not true, then we continue. I don't remember if like where exactly does this get used? Hold on. Uh so and so, so and so. Can I do this? Possible tokens. Okay, so this does not work. So I have to present it in a different way. Right? So let's say no, how would continue work here? Oh, continue is for loops. Okay. All right, just like if let, it works perfectly with tuples or arrays when you only want to proceed if a specific value is present. Okay, all right, then so we just read the irrefutable patterns thing. Rust will actually give you a compiler warning if you try to so and so so and so. Then refutable patterns, patterns that can fail to match. Um, for example, matching a specific number, matching an enum variant, some x, or matching a struct field condition. Sorry, zoned out. Okay, going back to, wait, no. Using your user struct, how would I pattern match for the name Alice? To pattern match for a specific string like Alice, you just need to place the literal string directly into the pattern where the name field is. However, there is one small Rust quirk to keep in mind because user.name is a string and heap allocated, and Alice is slice, a string slice literal. You can't match them directly without matching against a reference. Here's exactly how you would do it using iflet and let else. Okay, oh, dot to string. Wait, that's wild. Okay, so I can't just do. Why does this not work? String from. Like that could have worked as well, right? That gives us why is it saying no information available? String from ABC. There. Yeah, this returns a string. Okay. Name, user, name, so and so. Yeah, I'm confused about why that's not working. It's still not working. Okay, we match against a reference to user, so we can match the string field. Alternatively, you can match the literal directly. The idiomatic way with guards and match, because string versus string slice matching can be slightly clunky inside a pure if-let pattern, the most idiomatic way to match for specific string values in Rust is often to use a standard match statement with a match guard. Wait, this is crazy. You guys need to see this. Hold on. Hold up. Let's paste that. This is what Gemini is suggesting. Yeah, that was moved. So, um, wait, is there a code action for that? No. All right. And we might as well do it here. Give me a second. Okay. No, I'm still curious as to why. Okay, wait. Let's look at this code. So we have this if name is equal to so and so. I completely forgot that we can add conditions in here. Yeah, I think this is what's called a match guard. Putting a condition within the match arm. Okay, I'm confused as to why I can't just compare it in if let using string from the way I was able to compare um what was it? Admin with a boolean. Admin using just a boolean. Sorry, zoned out. Okay, that is a completely fair thing to be confused about. It feels like you can do if you can do it with a bool or an integer, you should be able to do it with a string. The core reason you can't use string from Alice inside an if-let pattern boils down to a fundamental rule of Rust. Patterns are not expressions. Oh, so it's not going to return a value? Like that's the issue. So we have to give it an actual value. True is like a direct value. But then why wouldn't a string slice work? Actually, okay, the reason a string slice won't work is because it's expecting a string. Like this thing is expecting a string. What if I did this? For the sake of comparison, okay? Oh God. For the sake of comparison, did I delete the str thing that I had? Yeah. For the sake of comparison, let's have str01 string from Alice. Now, would I be able to, does giving a variable as a thing count as a reference? Wait, wrong place. Hold on. Um, okay. Um, move this up. Okay, right. Can I do this? Oh, I can. Um, let's do a print line here. Names Alice. Okay, that works. That's interesting. Okay, I'm kind of getting it. Okay, not Rust. Gemini goes on to explain, here's a breakdown of why this happens and what's going on under the hood. So patterns versus expressions. In Rust, code is split into two main worlds. One is expressions and the other is patterns. Expressions, these are code that can, e- no, what? Expressions. Code that executes, calls functions, computes a value, and returns it. Patterns, a structural blueprint used for matching shapes of data. When you write if let so and so so and so, uh, true is a literal. So in this case, it's talking about this if let, and it's kind of interesting seeing like okay, could I just get rid of this? I didn't know I could just get rid of this. Let's remove this and just say Alice. No, we can't just get rid of it. Though, what if I use this, the dot thing? Could I just put the, would this work? That's crazy, dude. I need to look into the dot thing as well. Though I believe the dot thing is for I've mainly used the dot thing when we have to how do I say this? When it's kind of the dot thing is basically like the remainder, if that makes sense. So like you can when you're defining not defining when you're creating an instance of a struct, you can be like okay, I want so and so field, I want this field, this field, this field, and there might be like seven more fields remaining. So for that, you could do dot dot and then default. There's also, I believe, dot dot, and then you can specify another struct. So all the remaining fields are going to be read from that struct. Yeah, I actually forgot about that. Damn, I haven't used that. To be fair, I haven't been doing a whole lot of projects. I'm still like right now I'm getting into it. I'm getting into doing a bunch of projects. So slowly I'm going to be exploring a lot more of, you know, Rust. But okay. Uh when you write so and so, true is a literal. Rust's compiler knows exactly what true is at compile time. So it can structurally compare the memory. However, string.from is a function call, hence an expression. Okay, okay. It's a function call. It has to allocate memory on the heap at runtime. Rust patterns cannot execute code or call functions. Because string.from is an expression, the compiler will throw a syntax error if you try to force it into a pattern blueprint. Okay, help me understand why if I create a variable stro1 and give it the value string from Alice, um, I'm able to use stro1 uh, to match against name. Actually, if you try to use stro1 directly as a pattern on the left side of an iflet, the Rust compiler will still reject it. It's a super common misconception. Hold on. How is my code working then? Um, just to be sure. Okay. So it is giving a warning, to be fair. Irrefutable pattern, iflet pattern. No, irrefutable iflet pattern. This pattern will always match. So the iflet is useless. Consider replacing so and so. Um, all right. Get rid of that. Okay. But why is this code working for me? This is one of the most famous gotcha moments in Rust. The code compiles and runs, but it isn't actually checking if the name is Alice. What is happening is called variable shadowing. If you change user's name to Bob, you will find that the code still runs and still prints names Alice. Here's exactly what Rust is doing behind the scenes. The illusion of match. When you write name stro1 inside the iflet pattern, Rust does not look at the let so and so str01 whatever line you created upstairs. Instead, it thinks you're creating a brand new, completely unrelated variable that just happens to share the same name. That's odd, dude. Hold on, no, I need to explore this. There's a bunch for me to explore now. Apparently, even in Match, because I haven't used Match like in more advanced use cases enough to know about that or to remember that whole match guards thing. It is mentioned here though. Like, to be fair, match guards. Um, okay, catch all. All right. Where's match guards? I'm not seeing any examples. Yeah, yeah. I'm not seeing examples. I'm gonna have to look elsewhere for the match guard thing. Is hold on, is match guard is that what match guard is? Like the condition? I can't even remember that. So I'm trying to wait. In Rust, what is a match guard? Is it like a condition you put after the arm? Yes, a match guard in Rust is exactly that. An extra condition you attach to a match arm to add more filtering logic. Even if even if a pattern matches a value perfectly, the match arm will only execute if the guard's condition evaluates to true. Why use match guards? Pattern matching in Rust is incredibly powerful, but patterns alone can't handle complex conditional logic, like checking if two variables are equal or if a number is greater than 10. Match guards bridge that gap. Yeah, okay, okay. That makes sense because like matching is for matching patterns. It's not a conditional thing. That makes sense. I guess that's where iflet could help, right? No, no, actually no, I don't think. No, no, yeah, I think that's where iflet can help. I think so cuz we have this, right? Let's say I did 5 greater than 5 less than. Okay? Let's change this to less than 5. That doesn't work. Okay. Uh yeah, I guess this doesn't work for it. So I guess in this case we would then need to use, would iflet work here? Cuz this is supposed to diverge. What if I did this? Iflet 5 less than, does it work here? No, iflet would be used for something else. I'm using these things like in other ways than what they're meant to be used for. Also, I just noticed the time. Um, okay. Guys, I need to end the stream. Uh, I unfortunately started the stream late. Um, but yeah, I need to end the stream. I will stream again tomorrow, and I'm gonna try my best, dude. I need to work on like starting the stream earlier because the past couple of days I've been starting them much later, and then I'm only streaming for like an hour, and today it's not even an hour. Today it's like 56 minutes. So yeah, I'm gonna make an effort to try to be ready to stream much earlier so I can stream for at least an hour and a half or 2 hours or something. But yeah, that's going to be it for today's stream. I will continue with this matching stuff and if let and let else and all because I'm really interested in this now. There's a lot that you can do with this, dude. Holy shit. And there's a lot of like complexities of it that I need to understand before I can move on. In terms of moving on, I'm going to be going back to doing the clap stuff. The clap stuff is here. I don't know if I realized this yesterday on stream or off stream. But the debug thing, apparently this counting thing, clap arg action dot count, this basically means that we are expected to give a certain number of, hold on, clap bin. Yeah, we're expected to give a certain number of uh D's, D's nuts. We're expected to give a certain number of D's there. So it could be 1D or 2, or if we go more, then it says don't be crazy. So that was interesting. I believe I don't remember if I discovered this on stream yesterday or not, so I just wanted to mention that. But that's going to be it for today's stream. What was I? Yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time.